This is the first of our Friday videos that you're going to be having, and this is the last section of material that is going to be on your first quiz. So let's get on with it. This is called absolute value equations. And so as we've been working with equations, we know there's going to be an equal sign in it. We know it's going to be something we need to solve. But the concept behind absolute value is the thing that we have to understand the most. In the first blank, it is the absolute value of a number is defined as the distance a number is from zero. Okay, the distance that a number is from zero. Now, the connotation of absolute value goes with the fact that we're not worried about whether it is negative or positive, but we're worried about how is it defined as distance from zero. So when we're looking for absolute value, if I have a number line and I have a 0 and then I have a positive 5 and out here I have a negative 5, the units of distance from 0 to positive 5 is 5 spaces. But the units from 0 to negative 5 is also 5 spaces. So that's why when we talk about absolute value, we're talking about a distance, not a direction. So whenever you use the symbolism for absolute value, you have to take into consideration that that number could be going towards the positive side, or it could be going towards the negative side in order to get the answer that you're looking for. So if we have x as our representing a real number, then if we want to write the absolute value of x, it's written between two vertical bars, just like this. And the outcome from that absolute value symbol is always going to be positive, because it's always measuring distance, and distance can't ever be negative. So if we write the absolute value of 5, how many spaces away from 0 is 5? Well, it's 5 spaces. But the absolute value of negative 5 is also 5 spaces. So we're asking the distance from 0 for negative 5 is 5 spaces, because both of the numbers 5 and negative 5 are 5 units away from 0 on the number line. We're measuring a distance. So when we see the expression, the absolute value of x, okay, the x or the value that you might have between those absolute value bars, such as it could be 2x minus 7 inside those bars. Whatever we have that's inside of these bars could have been a positive number, or it could have been a negative number in here. But when you find its absolute value, it's always going to come out to be a positive number, because again, we're measuring the distance of what's inside of these two bars. So if we say if the absolute value of x has an answer of 7, then this x inside of here, inside of these absolute value bars, it could be a positive 7 in here, which means it's 7 spaces from 0, or it could be negative 7 in here, because it's also 7 spaces from 0. So there's always going to give two possibilities. So when you solve an absolute value, and that's going to give you two possibilities for solutions. An equation with an absolute value must also be solved in such a way for both possibilities for the solutions to be taken into consideration. So that means when you have an absolute value equation, you're going to have to account for two possibilities for answers. Whether that equation took you to the right hand side of 0 to get those 5 spaces, or to the left hand side of 0 to get those 5 spaces, it still has to be considered for both. So every time you solve with an absolute value equation, you're going to get two answers. So you've got to work two separate problems. Now here's how the equations kind of work in for it. So think about this. During a normal tidal raise and lower during a day, the tide can be as much as 2 feet higher, that would be a positive 2, or 2 feet lower, negative 2, than the average depth of the bayou. So let's say we've got a post here and there's a pier, okay, and the water line above at this pier, well, let's make this the pier, okay. The pier under here is the average height of this water would be at 7 feet. So what we're trying to find is the difference between what the higher number could be and the lower number could be. So the possibility could be that it was 2 feet higher, the tidal change. It can either be 2 feet up is high tide and 2 feet lower is low tide. So we have to consider it could be 2 plus 2 up here, which would make it how deep? 7 plus 2, that would make it at 9 feet deep. Or it could go down 2 spaces, so 7 feet dropping down 2 spaces would make it be at 5 feet. So when we solve an equation like this, it gives us it could either go up 2 feet or down 2 feet if we have a change of 2 in its value. So when we get an equation like this, that's what it looks like. That's what your absolute value is going to look like. So it says the difference between the two answer possibilities is going to be 2, but that means it could have been 2 feet higher or it could have been 2 feet lower, and that's what happens when we work with those kind of equations. So here's what the basic standards are when you solve an absolute value expression. First of all, you want to get that absolute value by itself, so that you just have an absolute value expression on one side equal to something on that side. So if there's any numbers in front of the absolute value or any numbers between the absolute value and the equal sign, we got to get those out of the way so that we just have absolute value by itself. Okay? So isolate the absolute value expression, and then once you get the expression by itself, you're going to break it apart and you're going to take the bars off of it. So you're going to rewrite the equation to account for the two possibilities. You're going to make it an OR problem. So either it went up 2 feet higher or it went down 2 feet higher. So either our answer is a positive 2 on one end or it's a negative 2. So here, when we look at this problem, we've got absolute value of x plus 1 has to come out to be a 2. So we're going to take, it's already isolated by itself, so we're going to take it out of the bars, and we're consider one of the cases would be if the difference was positive 2, and the other one with an OR in it would be that if it came out with a negative 2 difference. So you take it out of the bars and you set it equal to the positive version of 2, or it could have been the negative version of 2, because it depends on which direction it's going. So then you solve each one separately. They're little baby equations. Solve each one like we've been doing. So you're going to have to subtract 1 and you get x equals 2 minus 1. So x could be 1 or minus 1 minus 1. So I get x equals negative 2, negative 1 would be negative 3. So what this is saying, if you put either of those numbers back into that absolute value bar, the absolute value answer still is going to come out to be 2 spaces. So here, I'm going to just show you what the check step would look like. If I put positive 1 plus 1, and I take the absolute value of it, that means how far away is it from 0, it should come out to be positive 2. So is the distance from 2 the same as just 2? Yes, it works. The absolute value number of 2 is 2 spaces on the number line. So over here, if I put in negative 3 for x, add 1, and then I'm going to take the absolute value of it, is negative 3 plus 1, that'd be negative 2, and is the absolute value of a negative, oh, I'm sorry, I have to check it into the top, ignore that. I have to check it back into this equation, not to where I was there. So for each check step, you're going to go back to the original equation and plug it in. So is an absolute value of a -2 the same amount of spaces as it is for a +2? And the answer is yes. So you make two separate equations and solve it, and then you're going to have two answers. So on your homework, it's probably going to allow you just to write one x and then put a comma between the two numbers, or they'll have the x written in for you. Okay, so here, first of all, on your note sheet, you need to change this number 2, put a 2 in front of the bars. Change the 3 that's there and make that a 2. That was a typo on this problem. Alright, so the first thing it says is I need to isolate. So that means I got to get rid of this +2. So I'm just going to do what we do and move it 2. So subtract 2 on both sides. And then I've got a 2 in front of the bar. So then 10 minus 2 would be 8. But now I got to get rid of this. I still don't have the bars alone by themselves. So now I'm going to divide off this 2. Then I have absolute value by itself. So I have 2x plus 6 in its bars. And then over here, 8 divided by 2 would be 4. So now it's in a workable state. Until you get it to this state, you can't shortcut it and just go, okay, well, I'm just going to do it up here. She didn't tell me I could do that, but I'm just going to make up my own way to do this problem. If you make up your own way to do this problem and you don't follow these steps in this order, your problem will be wrong. One answer will be right, one answer will be wrong, and you'll be frustrated with it. So don't try to shortcut it. You just have to do it this way. So once we get to this one, we're going to account for the two possibilities. So either this expression inside 2x plus 6 was a +4, or the 2x plus 6 was equal to a -4. And then when you solve each one of them, you'll put yourself in the position to determine how far it went. So it's the same thing like we would talk about on this. So either a 9 with a change of 2 would put you at 7, or the 5 with the change of 2 would put you at 7. So we've got to consider both. So I'm going to subtract 6. Then I get 2x equal -2. So x equal -1. And over here, subtract 6. So I get 2x equal -10. Divide by 2, so x equal -5. Now, we're not saying up here, we're not saying that the answer can't be negative. We're saying the outcome from the bars. So if we take this and we go plug it back in, the outcome from the bars, when you take the absolute value of something that's negative, it still becomes positive. So here I can stick in a -5 and my answer will still result in an outcome that's positive. So if I put in -5, -5 times 2 would, let's go to the top, -5, so that'd be -10 plus 6. So -10 plus 6 would be -4. And then I have a plus 2, and I have equals 10. Then to solve this out, you go ask yourself, what is the absolute value of -4? In other words, how far away from 0 is -4? Well, it's 4 spaces. So 2 times 4, this would give me a +8, plus 2 gives me +10. So it does work. It's okay for x to be negative, but what you pull out of the bars, what comes out over here on this side has to be positive. Anything that can be inside here can be negative all the way around, but once it comes out, it has to be positive over on this side. So watch example number 3, watch what happens. If I subtract 4 on both sides, it's saying 3 minus 2y equals to a -1. So it's saying the distance measured from 0 in here is a negative distance. Can distance be negative? No. So that's where you have to think. This term right here, you have to think this is a distance. Okay? Distance cannot be negative. So on this particular problem, because we got a negative number over on the right hand side where it says absolute value is going to be negative, absolute value is never negative because it's measuring distance. So on this problem we would say there is no solution. Okay? So anytime that you simplify and you move the number over to get the absolute value by itself, and this number over here turns out to be negative, it doesn't matter what the rest of the problem is. If that says it's going to be absolute value negative, it can't happen, and the answer is a no solution, and there's nothing for you to work. So now when you get down on these two problems, you got some fractions here to deal with. This is one of the places that if you want to, you could put your fractions in decimal form, and it's going to be okay. And I'm pretty sure that on the homework it'll tell you that you can use a decimal value as just equivalent. So if you want to change the 1/4 here to 0.25, you can do that. So I would say 0.25x minus 7, put your bars around it, is equal to 4. So now I'm going to say, okay, my absolute value in here could have been a positive 4 to start with, so you take it out of the bars, and 0.25x minus 7, make it be equal, could be a positive 4 inside there, or it was a negative, and when you pull it out of the bars it becomes positive. So 0.25 minus 7 could have been a negative 4 inside. So now you're going to add 4 to both sides, so you have 0.25x equals to 11, and use your calculator. Divide by 0.25, divide by 0.25, and just work it out with your calculator. I think that's going to come out to be 44 when you divide it out. Over here, I'm going to add 7. So now I get 0.25, whoops, there's supposed to be an x right there, is equal to 3. Divide by 0.25, divide by 0.25, and the answer should come out to be, this is negative positive, the answer should come out to be 12. Okay, so you should get two answers, and it doesn't necessarily mean one is positive and one's going to be negative. Sometimes they both come out to be the same sign. Were we okay with this so far? Alright, now again on number 5, I would put that 1/2 as a decimal value. So I would just call it 5x plus 3 inside absolute value bars and make that be a 0.5 right there. And then you're going to take the bars off and you're going to set it as its two possibilities. So either 5x plus 3 equals positive 0.5 or 5x plus 3 equals negative 0.5. Okay, so now you're going to subtract 3 on both sides. So I get 5x equals, so I have a half and a negative 3. So if I have negative 3 and a positive half, that's going to come out to be negative 2.5. Divide both sides by 5. X is going to equal to negative 0.5. Okay, over here subtract your 3, so you end up with 5x equals negative 3.5, because you got a negative whole number 3 and a negative half, so negative 3.5. And divide by 5, you're going to get x equals negative 0.7. So either you get negative 1/2, negative 0.5, or negative 0.7 for your two answers. So absolute value, the thing you have to remember is that you must solve for two cases. So you're going to get two answers in your problem unless you have a situation like this where your absolute value bars end up equal to a negative number. And distance is never going to be negative. So this is a problem where if you have negative on the right hand side and absolute value on the left, it's just a no solution problem. There's not even any work that you have to do with it, but it's something that you just have to recognize that that's not going to work. So you should be able to go through your homework on these problems. Most of these examples are examples of a problem just like what you'll find on your homework. These notes will be, you should be able to just fill in your blanks along with this notes. And on Tuesday, your quiz covers 1.5, 1.6, 2.1, 2.3, and 2.4. So here's 2.3. Your quiz will be due on Tuesday. If you decide that you want to take a quiz early and then maybe you don't like the grades you made, you can wait till Tuesday, ask questions, or show me what you did, and then we can figure out how you can go back and retake it and make a higher score. So these are your notes for Friday's class, which we will not have to meet on campus. And so you should be able to be good with this. If you have questions, just shoot me an email or you can FaceTime with me, and if I'm available, I'll be able to help you. So I think you guys will do well, and I'll talk to you later. Bye.